Okay, let's dive into this. We talk a whole lot about the cloud, right? Wireless networks, data just floating around in the ether. It all sounds so magical, almost untouched by human hands. But today we are going to completely shatter that illusion. We're pulling back the curtain to look at the actual, highly fragile, deeply physical reality of telecom networks. Because the truth is, your internet connection, no matter how seamlessly wireless it feels on your smartphone, is fundamentally anchored to the physical world. It relies on real, tangible cables, real radio dishes, and real people who literally have to go out into the elements to fix them when things inevitably go wrong. There's this foundational training concept in the industry that I absolutely love. It goes, the internet is just light and radio waves moving through space or glass. Just think about that for a second. When you strip away all the complex routing software and those glossy, perfectly designed apps, this is exactly what it boils down to. It's just light. It's just radio. Over the next few minutes, we're taking a journey. We'll start way down at the micro level of those light pulses, and then we'll zoom all the way out to the macro level of massive network architectures. We're going to see exactly how your data physically travels from point A to point B, and more importantly, what happens when that journey is abruptly cut short. To actually transport these massive amounts of data, telecom networks essentially use three primary delivery vehicles. In the industry, this is known as the backhaul network. You've got fiber, microwave, and satellite. Now, each of these has a specific best use case, sure, but what's way more interesting, especially for the folks maintaining these networks, is that each one has a very distinct primary fault risk. And understanding these specific vulnerabilities, that's the real key to understanding exactly why your internet randomly goes down and what kind of crazy effort it takes to get it back up. Let's start by contrasting the two absolute heavyweights here, fiber optics and microwave. Fiber is the gold standard, hands down. It uses tiny pulses of light traveling through microscopic glass strands, giving you near limitless capacity. But get this, its biggest natural predator isn't some massive storm, it's a backhoe. Construction equipment snaps these buried cables constantly, which forces field technicians to go hunting for the exact GPS coordinates of the break. Microwave, on the flip side, is your reliable alternative. You don't have to dig any trenches, making it incredibly fast to set up. But it is entirely at the mercy of the environment. Heavy downpours cause what's known as rain fade, where the water literally absorbs your signal. And high winds, they can physically twist the tower, forcing technicians to check the received signal level, or RSL, just to figure out how badly misaligned the dish has become. And then we have satellite. Think of this as the ultimate last resort for backhaul. You're definitely not going to see this powering a major downtown city center, but it is an absolute lifesaver out in deserts, on remote islands, or in emergency disaster zones. Its superpower is pretty obvious. It can cover literally any spot on Earth. But the massive, unavoidable drawback is latency. Because that signal has to travel all the way up to space and back down, there's a noticeable delay. If you've ever been on a live voice call over satellite, you know exactly how frustrating that lag can be. Plus, for the field techs, the main challenge isn't dodging backhoes or fighting the wind. It's pure geometry. They have to do strict GPS verification to make sure that antenna has a perfectly clear, unobstructed view of the sky at all times. Now, working safely on these systems, that requires knowing some pretty intense insider trade secrets. Take fiber, for example. There's a very strict laser rule. The light pulsing through those glass strands is completely invisible to the human eye, but it is powerful enough to instantly and permanently burn your retina. Techs are warned to never, ever look directly into a fiber tip. Actually, scratch that. They aren't just warned, it's a cardinal rule. Instead, they have to use a specialized optical power meter to essentially see if the cable or the active SFP module is live. And microwave, well, those dishes are mounted at the very top of dizzying towers to guarantee a clear line of sight. Getting up there requires full harnesses, rigorous safety checks, and frankly, an absolute lack of vertigo. To keep our modern, data-hungry world spinning smoothly, network engineers use this brilliant pro tip called hybrid redundancy. Basically, this is where a cell site uses both a primary fiber link and a secondary microwave link. So if a construction crew snaps the fiber down the street, the system is smart enough to automatically fail over to that microwave dish up on the roof. Your Netflix stream might buffer for like a split second, but it keeps right on playing. But here's the catch. For the network technician, this situation is a ticking time bomb. Even though the site looks totally fine to the public, internally it has to be treated as a high-stakes emergency. They are essentially flying without a net now. A single secondary failure, like a heavy rainstorm hitting that backup microwave link, and the entire site goes completely dark. Okay, let's move to and see how this builds into the larger macro network. You can really visualize the whole network architecture like a giant pyramid. Up at the very top, you have the core,
That's the central brain processing absolutely everything. Down at the base, you've got the access network. These are those individual cell towers you see on street corners, the ones your phone directly talks to. But right in the middle sits the aggregation layer. Think of this as a central hub where dozens of those individual street towers all connect together to pool their data before sending it straight up to the core. Grasping this pyramid structure is absolutely critical to understanding what happens when this physical infrastructure breaks down.
And that brings us to one of the most dramatic realities of telecom, the funnel effect and the aggregation multiplier. Look, if a single access tower fails down at the base of our pyramid, one neighborhood loses service. It's bad for sure, but it's contained. But what if the backhaul cable that connects an aggregation hub to the core gets cut? Boom. The impact is instantly multiplied by a factor of 10, 50, or even 100. If an operator is watching a monitoring screen and sees 30 cell towers drop offline at the exact same second, they instantly know they don't have 30 randomly broken towers. They have one massively severed pipe sitting right in the middle of the network. Which, funny enough, perfectly explains this incredibly frustrating, relatable, everyday mystery. We've all experienced this, right? You look down at your phone, you see 4 solid, beautiful bars of 4G or 5G signal, but your browser absolutely refuses to load, and your messages just will not send. It literally feels like your phone is lying to your face. But it's actually telling you a very specific truth about a hidden bottleneck in the network's physical reality. This whole maddening scenario is caused by something called an orphaned signal. See, your phone is showing full bars because that local access tower right down the street, it's actually working perfectly. It's sitting there actively broadcasting radio waves, and your phone is successfully connecting to it. The actual problem is that the backhaul link, that critical fiber cable or microwave beam connecting the tower to the rest of the network, is completely broken. And because there are no magic backup airwaves to jump over that gap, the tower basically becomes an isolated island. Your data travels from your phone, hits the tower, looks for the bridge to the internet, and finds that the bridge is completely washed out.
And the real victims of these physical bottlenecks are incredibly densely packed. In our modern 5G era, a single backhaul pipe isn't just carrying a handful of phone calls. It is quite literally the lifeblood of an entire district. Cut that one fiber strand and you're instantly knocking thousands of mobile users offline. But it doesn't even stop there. Very often, local home fiber internet connections running on FTTH or GPON infrastructure, and even critical enterprise links for local businesses and banks are all running through those exact same physical conduits. One misplaced shovel on a random construction site can literally bring the commerce and communication of a whole neighborhood to a grinding halt. Let's look at how this plays out from the customer's perspective, because this false positive creates a massive ripple effect. First, the user sees full signal but no data. They try refreshing, nothing. Then, figuring their phone is just glitching out, they reboot the whole device. Finally, when absolutely nothing works, they get angry and they call customer service. Now take that journey and multiply it by thousands of people in the exact same district. You get a massive, sudden surge of angry phone calls that completely clogs up the help desk. This right here is why a field technician's speed is so vital. If a really sharp tech can diagnose a cut backhaul in just a few minutes and get traffic rerouted, they can literally stop a massive avalanche of customer panic before it even gets rolling. So the crucial point is really the intense, entirely unseen pressure placed on these field technicians. Because these backhaul failures wipe out service for so many thousands of people all at once, they get immediately flagged as high visibility incidents. Make no mistake, this isn't some relaxed Tuesday afternoon repair job. When a tech is out in the field trying to splice a severed fiber or realign a microwave dish in the middle of a storm, their managers and the network operations center are constantly breathing down their necks, demanding updates. The true mark of a professional in this industry is keeping their cool under that immense pressure, fixing the fault rapidly, and never, ever letting the panic cause them to skip critical safety steps like that laser rule or their harness checks. So, as we wrap things up today, I want to leave you with this thought. Just think about your day so far. Your GPS navigation, your banking apps, your streaming, your group chats. How much of it feels completely, flawlessly wireless? And yet, underneath all of that, how much of your daily life is entirely dependent on a single, incredibly fragile strand of microscopic glass, buried just a few feet under the pavement you walk on every single day? The next time you look down and see full bars, but your internet hangs, you're going to know exactly what's happening behind the scenes. And hopefully, you'll think about those unsung technicians out there racing against the clock to repair those invisible threads.